Hello and welcome back. So this is the next video in our series about linear equations. And what we're going to look at today are three different kinds of word problems that involve linear equations. So let's get to it. Okay, so let's take a look at this example of a word problem. A local bowling ball alley charges $3 to rent a pair of shoes and $2 per hour to bowl. Write an equation that expresses the total cost to bowl for X hours you must rent shoes to play. All right, we know it's a linear equation because I said so and because that's the title of this video, but how would we know this from the word problem? It's this right here, $2 per hour. That is telling us that we have a constant rate of change, that for every hour, we spend $2, and that is constant no matter how many hours we spend. If we're there all night, we're spending $2 for each of those hours. And constant rate of change, the definition of a linear relationship. So, you know I'm all about the formulas. I'm going to write down my slope-intercept form, y equals mx plus b. Okay, well, this constant rate of change, that's our m. So y equals 2x plus b. Now, what's the b? The b is our thing that doesn't change. Our 2x is going to change depending on the x. But what's the constant, the thing where if we bowled no hours, but we wanted to hang out in the bowling alley, how much would we spend? Well, it says you must rent shoes. So that means our $3, that's our constant there. So y equals 2x plus 3 is a linear expression for the total cost to bowl for X hours. So let's check that out with a little bit of a t-table here. So if we think about this, if I bowled for 1 hour, well, $2 for 1 hour, that would be $2. And then I must rent shoes to play. So that's plus $3. So for 1 hour, I would expect to pay $5. And that's what my equation tells me too. 2 times my 1 hour, 2, plus 3 gets me a total charge of 5. Let's say I'm having an all-day party and I want to bowl for 10 hours. $2 per hour, 2 times 10, that's 20. And I have to rent that pair of shoes for 3, that's $23. And then as we said, let's say I just went in, but I decided not to bowl, but you must rent shoes. So at 0 hours, I would just pay my $3 for shoes. And so this is my word problem. This is my equation that expresses the total cost to bowl for X hours. And then this is the t-chart that it generates as I put in varying amounts of hours. So that's a first example of a problem. Now let's take a look at a second with a little bit of a twist. Jessica and Jen run a bake sale to earn money for their choir. They sell cookies for $4 per cookie, and their supplies to make the cookies cost $10. Write an equation to express the amount of money they have earned to give their choir after they cover their costs. Okay, linear equation, because I said so, but also because $4 per cookie is a constant rate of change. Writing my equation, y equals mx plus b. My constant rate of change is my slope. Y equals 4x plus b. Okay, but what's my b? Well, it says I want to express the amount of money they earned after they covered their costs. So here's where this problem is a little different. We see this 10 and you think, oh, well, 10 must be the b, right? It costs them $10 to make cookies. But if that were the case, if I put 10 in here, then that would indicate that after they sold one cookie, 4 times 1 is 4 plus 10, that they would have $14 to give their choir. Now we know that that's not true because they started having spent $10. So in this case, our B, the place we're starting from, is negative. They have $10 of debt that they have to overcome before they start earning money for their choir. So when they sell one cookie, 4 minus 10, they will still owe themselves $6. Whoopsie, I said 4 and that meant to be a 1. Okay, when they sell 2 cookies, 2 times 4, that's 8, minus that 10 they spent, they will still owe themselves $2. But when they sell that third cookie, 4 times 3, 12, minus the $10 they give back to themselves, they will finally have earned some money for their choir. And then so on and so forth. So to express the amount of money they have after they cover their costs, we take the amount they get per cookie times the number of cookies they sell, but we have to subtract that $10 because it cost them $10. Okay, so that one's a little bit different. Our B is negative because of the wording of the problem. And let's look at one more example. And again, this is kind of changing things up. Ron lives 50 miles from his grandmother. He bikes toward her house at a constant rate of 3 miles per hour. Write an equation to express Ron's distance from his grandmother's house as he bikes. All right, right here, constant rate. That lets us know linear. Y equals mx plus b is linear. All right, constant rate of 3 miles per hour. Okay, so we know that our slope wants to be 3, but we have something a little different going on. He lives 50 miles from his grandmother's house, and as he bikes, he is getting closer to his grandmother's house. He is decreasing the distance as he bikes. So that means these two terms, y equals, it's actually these 50 miles that he needs to cover minus the amount that he has traveled. So we know that he is traveling at 3 miles per hour, 3 times some x. But to write the equation to express how far he is from grandma's house, we need grandma's house minus the amount he has traveled. So y equals 50 minus 3x. And again, that's because of the wording of the problem. So let's draw a little picture. There's Ron, and there's Grandma. And we know that this is a distance of 50. And we know that he is biking at 3 miles per hour. So for example, after he has biked for 1 hour, he has covered 3 miles. How far is he from Grandma? Well, we know he's 47 miles from Grandma. And how do we know that? Because we did 50 minus how far he traveled. After 2 hours, we know he will have traveled 6 miles. He will be 44 miles from Grandma's house. See, even tutors make mistakes. And how do we know that? Because we did 50 miles minus the amount he traveled. And so then if we want to do that after he's traveled X hours times 3 miles per hour, that's our 50 minus 3x. So again, let's take a look at these 3 different word problems and how we knew how to do them each differently. So we have our first one, and this one's pretty straightforward. We have our constant rate of change, and we have our initial cost. And so that's our mx and our b, y equals 2x plus 3. For our next one, what changed is that instead of having an initial amount to pay and then more money to pay, we had money being earned and we had outlay of money. That means that that initial amount, that's debt, that will be expressed as a negative. And then finally, we had a total distance, but then we're closing the gap, right? This amount should be getting smaller each time. So that means instead of mx plus b, we have b minus mx. So we had 50 minus 3x. So that's 3 different linear word problems and the different language that's used to tell you what to do. All right, so algebra students, you still breathing out there? Word problems are hard because every single one is a little bit different depending on the wording. Study these 3. Take a look at what let you know that that $10 that they spent before they started earning meant that B was going to be negative this time, or what that idea of closing the distance to grandma's house meant we were going to do B and subtract our MX. Okay, and keep looking out for those kinds of wordings. Draw pictures if that's helpful as you attack each word problem. And I'll make another video and I'll give you 3 different kinds of word problems so you just get lots of exposure here. All right, you can do it. I believe in you. And as always, keep mathing.